you want to be set up to see a counselor or whatnot. Yeah, send me that. I'll send it to them. Okay, so we are gonna cover the last day today. We're not gonna have a lab today. I have to leave the campus and be able to travel, but and I'll post the video from yesterday. I'll try to do that before I go. So today we're gonna talk a little bit about protocols and then routing and then troubleshooting. So let me share real quick, otherwise my video will have no image, just me talking. All right. So in network environments, protocols, as we learned, that it really established rules for system to follow for communication. And different protocols are used for different activities and services. So for example, if you transfer file, which is FTP, like I can put my file into a file server, a file transfer type of server. Mozilla has one. It's a public FTP server. It's a little bit different than what you see in like storage server. It does store files, but when you log in, you're able to upload your file to share with other people, or you're able to download. And companies would use FTP server to be able to distribute things like documents about benefits or companies information or some kind of services they offer. You don't see as many public FTP server anymore. And so in IT and cybersecurity, if you implement a server that's able to do that, you would use a port, or that would be either number 20 or 21. And typically, this is the port that the industry agrees on for this type of service, right? So protocols are always going to be tied to a certain type of service. So FTP, this means it's not secure, right? Like the files that goes to the server, um, someone that now logs in can download your file. And sometimes they don't always maintain malware control in that type of environment. And it's not exactly like file sharing in music or video. It's a little bit different in that you would be able to access it with a credential. Now, in the past, FTP does not require credential. You can just use an anonymous account. Username is anonymous and a simple password or sometimes no password. But now we're implementing FTP with some kind of credential so we can track who's accessing what. And that's what we call accounting in IT. Um, Now, if you have a server that is used for email delivery, so for example, you are logging into your student email account that is being provided, your inbox and your draft and your outbox is maintained and implemented into the email server. Many businesses use Microsoft Exchange as a product for email server. And in that configuration, that email server uses Simple Mail Transfer Protocol, your SMTP. And this uses TCP port 25. And we talked about TCP, that TCP makes sure, right, that there's communication before the data is transmitted. And then there's acknowledgement between the systems. So whether after, you have to connect and then there has to be some kind of acknowledgement who's sending, who's receiving, and then there's confirmation for that communication. So you can see that some protocols uses TCP. TCP is a protocol, but it's under that suite. So it's either UDP or TCP group of protocols. And so when we're using email server, that uses SMTP. Now, when it's not a server, if you're using like you know, how you are logging into your Gmail, your Yahoo, your Outlook.com, Live.com. Um, when you're accessing web mail servers, the client system yourself through the browser is using post office protocol. I think we talked a little bit about this a while back. And post office version 3 is a way that we can get web email to the user. You have access to Canvas. Have you checked? You're on there.
Yeah. Okay.
Okay. Yeah, I see your name on there since yesterday. But if you don't have access, then how are you gonna be able to submit assignments?
Well, I'm gonna figure it out after space and really go there.
Okay. Okay, let me grab the file for you while some of you are putting this down. All right. And so if you are a user and you're using web email, like what I mentioned, like Yahoo or Outlook.com, right? Gmail, then you're accessing POP3. And post office, just keep in mind that there's not only one server that is transferring your email, right? So your company server is going to be the primary server that you authenticate to access your email account. However, there are other servers that are going to be handling your email, just like how the post office, you don't have just one location that's going to transport your package. You have multiple post office locations that's bring your package from Moreno Valley, California to maybe New York, right? And then you have for question number D, client system downloading or searching email using email header. So in an email, the email header contains where the email is going to, like the addresses that you put, who is sending the email, so the source address. And then in addition to that, it also includes like uh, the servers that are handling your email. And the system uses this to be able to get it to the right destination. But in forensic, we also look at it in a way where we would see this to see if, for example, if a malware is being added to the email, right? There's files. So when you're searching through your inbox, which I do a lot, right? I don't really delete a lot of my emails in case I need to go back to it. Or if you are downloading like an attachment from your email, you're actually using a protocol called Internet Message Access Protocol, which is known as IMAP, and it uses port 143. So these numbers are assigned to specific protocol, and logically they're used as windows or doors for the system to receive and send. And that's how we're able to see what's coming, what's leaving, right? What's being used on specific system. Now, if you are accessing Windows remote desktop, which is a very common protocol these days, since that we have a lot more remote workers, then you would be using what's called remote desktop protocol. And this is particularly RDP is for Microsoft. So if, for example, if I'm at home and I'm the network administrator for my system and I need to configure my server, I can remotely connect to it as long as I set it up to do so, and be able to configure or reconfigure my system, right? And you see a lot of this being used for cloud-based servers. So when we say cloud, ultimately that is simply just a server in another location. You might be leasing it from Amazon or Microsoft, and you would be able to access it. And you would see a lot of them are being used as virtual machine. And so you would be able to you will be able to log into. Okay. So RDP uses TCP port 3389. Now, does it have to be this particular port number? In general, when you set it up, that's the default port that the industry uses. Now, some administrator, as I mentioned last time, they would use uncommon port, right? Like you can assign a different value to that particular service and be able to set that up. But by default, and if you are just using it out of the box, it's going to be 3389. Remember how when I show you the Wireshark? So when you're looking at packets that are coming across the network for all the systems that are sending and receiving, it ties the protocol to it. We talked about that yesterday. And typically you would see the port number, right? So it uses that particular door to be able to deliver that communication type of information. And then when you're accessing your HTTPS website, for example, Canvas to log into your class, right? You put in your username and password, and it establishes a session for you to click on your class and be able to submit assignment. In the back, HTTPS is Hypertext Transfer Protocol Secure. The S stands for secure. So in the back, it encrypts your data as you use it. And you want to use HTTPS versus not using it, which is HTTP. The reason why is that it uses transport layer security, which is TLS. I think they're at version 3, and then or secure socket layer, which is SSL, to be able to encrypt your data as you're accessing that website. Now, it doesn't mean that they cannot see your information, the attacker, right? So if someone is trying to look at what you're doing, so let's say that I have a user who's accessing their investment account and be able to maybe process a transfer of funds from their investment account to their bank. So in that process, they would use secure web applications which exist on these web domains, right? And once they authenticate, it create a session. And in that session, it's supposed to protect all the information, including their accounts, how much money they have, what kind of password they use, right? And if you ever notice on the secure website, if you click back, right, it makes you log in again. It ends that session. And each session has a session ID that's tied to that particular time. Now, it's all about configuration on how to protect it. But anyways, these two protocols are used to protect your information as you're using the web for data transfer. And so in that, it would then use port 995 for TLS and then 465 for secure socket layer. Now, when they implemented the web application, so when I say web application, like when you go to a website and you click menu and you click the tab on the menu, like for example, I click make a payment, right? With my credit card, that's part of the app, right? That's a feature in the app. So what we see is that some company, they would prefer to use transport layer security. Other company would use SSL, right? SSL in the past had problem with Heartbleed where there's a flaw in the actual protocol where people can breach it. And you see that, they can strip SSL. So that means that they can remove the security element in that protocol. It's not impossible, right? So in attacks, the way we look at it is that it's about time and resources. So if someone is really aiming for that target, they're going to look at like session ID, what kind of information potentially. So they're going to try to discover some information to be able to take away the security element to be able to access that information. So But it doesn't mean that we shouldn't use these protocols. So as you know, that technology is only to its best, right? And the industry for cybersecurity, the way we look at network protocols is that they are built a long time ago. Even with the latest updates, you're gonna tend to have some flaws. So, you know, there's no 100% security in anything, right? If you're using a web service, potentially your information can be out there, right? If they really want to pursue it. And then if you are using SIP or session initiation protocol, this is used for multimedia communication sessions, like when you're doing a phone call or a video call, like using Zoom, video conferencing, streaming for distribution, like using Twitch, or when you're also doing instant messaging. Like in-game websites over the internet, you are using SIP. And so this, because it's multimedia, you tend to see that it would use UDP. And we talk about the difference between TCP and UDP in that TCP makes sure that there's acknowledgement and confirmation in sending, receiving, and connection, where UDP doesn't do that, right? It just like send, like we talked about how if we send a package and if it gets there like 10 days later, it's fine. As long as it gets there, compared to TCP, it's going to be like, oh, you have to be home at 3 p.m. today to sign for the package. And that's how it works. That's the main difference. So TCP is definitely more reliable, but if you're using TCP only, what will happen is you cannot stream as fast. Your video is going to take a little bit longer to load because now you have to wait for that communication to be established and acknowledged. You see? So you tend to see multimedia being used with UDP. And it uses port 5060 or 5061. And then there's something called the Simple Network Management Protocol. This protocol is used to check, right, like inventory of the system. So if I'm in an environment where I have 3,000 computer, do I really want to physically go and check to see if they're connected, right? Or in the case where if I need to manage them, right, like if I need to be able to send updates to them and so on. So SMP is really for the administration of the system. It is used to check to see if the systems are connected, if the system have the resources. You can wake the system up, from one management computer versus running around from room to room to be able to do that. And it uses UDP 161. Now, if you are in this industry, you must know port numbers, right? Like in security, when I teach security classes, when you scan your tools, it's going to tell you which port, which windows and doors are open for that system. And you would say, okay, port 161, that means that that system is using SNMP, right? So if on the inside, if we're managing the system, right, we configure it and we monitor it and we look at the port. On the outside, someone is attacking the system. They are looking at your system on which door and windows are open as well, right? And then if you want to synchronize time, and this is what you see with daylight saving for us, right? You attach to Verizon, AT&T, T-Mobile networks. And so as long as you're connected to a network, you don't have to go and change your clock, right? It automatically updates the time as you need to. So on a user end, you see that network time protocols used. They implement servers for this, right? It's not just like for changing the clock, it's actually for synchronization of databases and systems. Because in a lot of the software, you only have a certain window to really synchronize. I'm going to give you an example. A lot of banks do batch job, right? You go to an ATM machine, you withdraw $40. An hour later, you go to 7-Eleven and you bought a drink, right? Using your debit card. And then throughout the day, you make purchases. So when you're looking at your transaction information, it says pending, right? It doesn't take effect right away. So what they do is at the end of the day, sometime late at night, right? It's automated, but in the past it's manual. The system actually synchronized. So it's going to look at the transactions for every single account as a batch, a group. And then it's going to update the database saying that so and so withdraw this money, so and so purchased this amount, and it's going to update the account in the batch. Now, in that process, you must have time synchronization because system is pulling the information. You don't want to have offset time. So for example, you don't want to look at a statement and say a day later that process that transaction, you understand? It has to say that that's the timestamp and that's the day and that's the moment that you make a purchase at 7-Eleven, right? So it's also for other servers with authentication. So for example, I have a company and I hire new employees. I create their account as an onboarding process for them to log into their system, right? By default, Microsoft gives you 60 minutes to replicate that information. So at the corporate office, HR is going to enter the information, right? So and so was hired. IT is going to then take that and put that into create an account and add their default password or whatever in if it's Microsoft, it's Active Directory. And then I don't want to take that information and copy it and send it via email. What the system does is that you might have many branches throughout the nation. So it's going to synchronize based on the primary domain controller. And it's going to trickle down and it's going to send that to, let's say, that person who works in California and the corporate office is in New York. So within that, it needs to happen within that hour. You can also configure it to be more immediate. So that way somebody somewhere else in the nation can log in and access without having to wait the next day or when their file is being sent, right? So it's a process in just to really maintain the consistency in time across. But then you ask, well, what happens when you have companies that are worldwide, right? Here in America, we're on a different time zone. Somewhere else in the world, like let's say that I own a company, a location in Japan or Korea or Indonesia. How is that going to work, right? So we use UTC, which is your universal time, where that time is agreed with the system. So no matter where you are in the world, you're still going to have the same time, right? And that time difference is really important because it's critical in, a lot of things beyond security and so your data it has accuracy and it's instantaneous and so on. So that's important. Okay. And then we saw DHCP yesterday from your wireless router. It gives you an IP address when you connect to it. So outside of the wireless router, it's an actual server role, right? It's a system that we add a role. It's kind of like, you as a person have many roles. You can be a parent, a grandparent, a son, a daughter, you can be, a student, you can be a worker, right? An employee somewhere. So the way that our system works is that you can give them multiple roles and in each role, it's going to function and do the things that you ask it to do. So your wireless router have many roles, right? It routes your information to the internet and back. It gives you an IP address when you connect your device to it. It also protects your information, so it functions as a firewall to filter some of the bad stuff out. So it holds many roles. Remember that the computer system really mimic the human action, right? And you start to see a lot of that in AI nowadays, right? Because we really built the system to do the stuff for us. So in a network environment, it's the same, right? I don't want to run around and having to manually put the IP address into each system. So I'm just going to make a computer that has a list of IP addresses and it's automatically distributed as soon as the other computer boots and connect to my network, right? So it streamlined the process for sure. Okay, so that uses UDP port 67 and 68. Now, and then next week we'll talk about like how these roles play into not just IT operation, but the from a perspective of like the inside the defender and the attacker, right? All right. Any question regarding protocols? Yes.
What does a TCP and UDP stand for? Is it not really?
So TCP is transmission control protocol, so it makes sure that things get there reliably. And then UDP is user datagram protocol. And that is like, it gets there, it gets there. There's no confirmation, right? So comparison is like you ship a package and you require a signature from someone, that's TCP. UDP, you just ship a package, train, plane, whatever, right? As long as it gets there. So if it's 2 weeks later, it still gets there. So UDP is tend to use for things that can be not as important in the data getting there at a specific time window. Like multimedia, the user will wait. I think, because raw data comes and it comes and when it arrives. So TCP, the way that it works is it waits for everybody to get there. And then it looks at the sequence and say, okay, I'm going to put the bicycle back as a bicycle and then gives it to you. Whereas UDP, it's like, oh, here's a handle. Oh, here's a wheel. Oh, you're missing that? Just wait, right? Oh, here's the pedal, right? So it's going to hand you the things that it gets. Whereas TCP, it's like, oh, we got to put everything back. So it takes a little bit more time. And then the communication is, so some service we have to use TCP, like your HTTPS. Whereas other services, UDP is okay. Okay. So a router, we saw the wireless router yesterday, but ultimately we have a box, right? And this machine routes information into your network and out from your network to another network. So the router is a transmission system that takes you to the internet and back. It has a public IP that's assigned to it. So when you configure the router, you give it a public IP. The switch gets the data, like I said, to your actual system inside. It works more on the inside unless you're using layer 4 or layer 5 switch. Okay. So the way that the router works is that there's no one specific route. There's dynamic routing and static routing. Static routing is like you can set it. So I'm going to give you an analogy. It's like, how you drive from home to school and you take that same path every day, right? You tell yourself that I'm going to turn right here, I'm going to turn left here, maybe I'll take the freeway for a few minutes, get off, and get there. And you won't change your path, and that's the only path that you take no matter what happens, right? And that's a static route. So sometimes in the way that we use the system, it's really for the goal or the objective. So in the case where you want to set that the router 1 is going to send to router 2, to router 3, to router 4, and eventually it gets to the destination. And no matter what happens, right? But in dynamic route, it's kind of like I open my Google map and I started driving and it tells me that, oh, there's an accident on the freeway. Now it's directing me to, take the inside street. So routers, what they do is they communicate with each other. And these are autonomous systems from one network to the next, right? Like you can say Charter to Cox. Cox owns a lot across the United States. And they have many. So what they do is they ask each other, right? What are you doing? What are you handling? Are you available? Right? It's kind of like when we're looking at our Google map, it's saying that, oh, if you take, a detour, you turn right here and you can still get there in time. And that's how it's able to really get your data to a destination quickly, because if we rely on a static route, it will take a long time in the case that if the main routers are busy, right? So what it does is it checks the other router. It's going to say, hey, let me see your table, right? Let me see what you're doing. Let me see which system is talking to you, right? And then and when it looks at that, it says, okay, I need to get the data from point A to point B, and in between there's like 15 routers, right? But let's say two of them are kind of are down, then we have to look at other routers now. So it asks, I call these routers and the nosy neighbors. So it's going to be like interrogating the other router saying, are you available? Are you available? Can I pass it to you? Can I pass it to you? Right. And that's how it's able to get it to the destination. Okay. So I talk about static route. So each router contains a certain path. It's kind of like you follow that street and the next street and the next street until you get there. There's no other way. Right. And so when do they actually use static route? Let's say that I am an agency in the United States, right? Like I have highly sensitive warfare information. I only want my router systems to be able to transfer data, and I set up that dedicated path, right? So in the appliance, in your box, you configure that. You can say router 1, router 2, router 3, and that's how it's going to pass. No other way, right? And they have specific protocols that they use for that, okay? Depending also on the vendor. Dynamic route, I talk a little bit about that. So it routes it to wherever based on the routing table. So I'm going to show you how to find your routing table. Yes.
I don't know if it's a little different, but like you probably know, like in gaming, sometimes when it's like it'll say like packet loss, that kind of like the same thing.
Yeah. So it tracks the packet. So packet loss, your system is gonna then regenerate that no matter what, right? Unless it times out. So it's gonna reattempt, and all systems have like a certain amount of time for timeout, right? It's really designed that way. So in a packet loss, what happens is it didn't receive. Okay. And then the sender is going to then retry that, or, sometimes it gives you the option, do you want to retry? You click yes, and it's going to regenerate that again, right? But in this case, it might pass it to other routers, right? Instead of getting there. It's kind of like, you wait for someone to get there and they're late. Possibly that something happens. And so, and then instead of waiting for them, maybe you ask another person to come, right? So then they will take a different route to get to you. It's the same data, it's just gonna be like another system that's gonna handle it. Now, autonomous systems are used for dynamic routing. So autonomous systems are routers, right? And routers, these autonomous systems automatically just like update the table. So how do I see route? I'm going to show you how. So if you open up command prompt, because was like part of our lab, but I'm going to kind of just show it to you. So you can type command prompt or CMD in Windows, and you see something like this, right? Now, I can see like where the information routed from my computer doing this. Just remember that you are accessing route table for this computer, okay? Not the router, this computer. Now, route is a command that is accepted in most systems, including router. But in some routers, you're gonna have to add options to it, like route, and we're gonna do a route space capital all caps print. Route print. So it tells me that these are my interfaces. Those are just adapters that's used for sending and receiving, right? And you see some of them are virtual, like for VirtualBox, right? NCAP is for Wireshark. But technically, I'm only using the Ethernet adapter. That's the first one, right? The killer E2500 for my Alienware, the school computer. And then I also have a Wi-Fi. You saw that yesterday, the Qualcomm, right? So there's two physical adapter on these computers for communication. The other ones are for virtual environment. So your virtual system sees itself as a computer. So it sees that there is an adapter, but it uses your host. Okay. It uses your real computer, but it has to have that object. So that way it can send from the virtual environment into the actual physical system. That's how they write the software. Okay, yes.
What does the IPv4 stand for?
IP version 4 is like these type of address. When you see the octet, there are 32-bit. So V4 uses 32-bit addresses. So like the 10.151. So this is the IPv4 address. The IPv6 address, they don't use it. Oh, it will look something like this. Yeah, so we ran out of IPv4 in 2011 for public IP. So just think about that. Like, let's assume my analogy is that Moreno Valley runs out of home addresses to give, right? So if you build a home, how are you going to have a home without an address? So there are companies that hoard IP, especially big tech company like Microsoft, they have a lot. Cloud company, they have a lot. So public IP has ran out, so they are reusing some of the IP, but they came out with IPv6. The difference is that the number system that you use, this is a decimal number system, and decimal goes 0 to 9, right? And with 32 bits, so you have 2 to the power of 32. It is less than 2 to the power of 128. So in hexadecimal, you have more combination of addresses. Okay, so that's, you see some network addresses are IPv6 like this, and then internally we see a lot of IPv4. So IPv4 is a type of address that's being used, right, for your systems. Same thing with IPv6. IPv6 is newer, and they would use IPv6 with IPv4, so that way, your system can communicate in case they run out of IPv4. Okay, so here's your routing table. It tells you that this is the table for version 4 IP. Now, when you see subnet masks that have 255, 255, 255, that's a broadcast. It sends to everybody. Okay? It's kind of like I stand in the middle of the road and I said, here's some information for the public, right? And then I just say things out loud. Everybody hears it. Compared to when you're not doing that, when you're doing a single cast, which is like 1-to-1, or a multicast is 1 to a group. Now, if you're using IPv6, it organized that into also a list, right? But IPv6, when you see the colon like this, those are just means that there's 0 in between. Okay? And these are hexadecimal value, and you have longer IP addresses, 128 bits versus 32 bits. So exponentially, you are much higher. Will we run out of IPv6? Yes. And there will be another version. They're saying that your MAC address is getting low because, there's so many communication system like wireless adapter and network adapter. So eventually you will get, let me bring 3 down. Eventually you will get maybe a different format. Okay. So routers function differently depending on the protocols that they use, right? And why so? Well, some routers are made by certain vendor like Cisco. And Cisco have their own set of rules for their system on how it sends and receives. Whereas and they also have a universal protocol. So all the companies, regardless of what brand, you would typically see that they would have a universal set of protocols and then their own, right? Just like how you have Apple systems, it has specific things for Apple, and then but it has like the general things that you can use universally. So the way that it routes is one, it's called a distance vector protocol. This is like using Google Map and finding the best way to get from where you are to school, right? Google will tell you that, based on the route, you're on your best path. So what it does is it measure the distance or the number of routers that handles your data in between. 30 routers is higher than 20 routers, then higher than 12 routers. So it's going to go with the least hops so that way you can get there sooner. It's kind of like Google Map tells you, right? If you go this way, it's 12 miles. But if you go the best path, it's 10 miles, right? So it measures miles times. And some of that is the distance in the street that you travel. Okay. Or like when you buy plane tickets, right? If you fly directly there, right? It tells you, maybe 4 hours or whatever. And this is the amount of time that you're going to use for flying, and this is the miles. But then if you want to stop in like Colorado, right? You would spend longer time and the distance is more, right? So distance vector look at the number of routers. They're called hops, and it weights based on that. Okay. So it's judged based on the distance, the path, and the least number of routers. So in computer science, in my discrete structure class, we talk about graph and tree because as software engineer, they have to kind of know how to be able to program something like this, how to be able to assess and measure, right? So I give them a project, right? Like travel salesman is a very common case for computer science, right? If a salesman go from city to city to sell, right? We have to look at the total number of distance from one city to the next, and then they have to come back home. So what's the best route, right? So you see a lot of this, and you have to be able to build it out in software. Another router might use a different protocol. It's called link state. And this is only going to measure based on the shortest path. It's different than the best path. So they get confused, right? My students are like, wait, can it be the same? Yes, it can, right? So the best path can be a shortest path, but not always the same. So I'm going to give you an example. Google might give you a best path, right, to get there because the shortest path has car accident. Understand?
Mm-hmm.
But sometimes it's exactly the same because it's the only path. Okay. So, and in the algorithm, they are different. So what you do is you really look at, so each router has a table, it tracks, right? And it's going to look at the neighbors to see how many. So if I pass it to the next router, which is neighbor number 1, that neighbor might be passing to 3 other routers. Okay. So the hops becomes more, where if I pass to the neighbor number 2, they only pass it to 2 other neighbors. So it compares the route table, and that's how it's able to determine, is it the shortest path? Least hops. But you remember, yeah, sometimes it can be the same, but shortest path typically is a different element. Now, the unique thing about link state is that they send each other's update. It's kind of like I ask my neighbor, right? What's going on with you, right? This is what's going on with me, right? So it reports its route table. It says, oh, I'm very busy. I can't handle this right now. Give it to neighbor number 1 or give it to neighbor number 2, right? So it's able to have a link update for the link state. It's very straightforward. And then you might have a lot of the more modern routers, they are both, right? And you want that because it's able to do the best things. Okay. Any question? So if you are going to go for Cisco certification, you must know these things well. Like their routing protocols, Cisco also have advanced base type of certification, especially for routing and switching. We have CIS-40B for that type of preparation. And then Network Plus kind of, it's going to ask a general term, like what is a distance vector? That kind of stuff. So if you understand the difference, right? Yeah, router is a course on its own. It's not a, so if you have Packet Tracer, I encourage you to use it, right? That's part of the project that we implemented with Cisco Academy. And it kind of teaches you on how to kind of program it or configure it. Okay. So I'm sorry I took that away from you, but I'm gonna open the notes real quick. So I want to point back to the notes because the notes contain a lot more information than what we would see in our assignments. I only use the assignments to summarize the important topics or the primary topics. So these are the categories of the routers. And then so if you are routing IPv6, we saw that in the table earlier, it's typically the same protocol, but for that version, right? So they have to be able to accommodate the new addresses. So when we talked about shortest path, that will be your OSPF. And if you're using version 6 IP addresses, it would use version 3 of that protocol. Whereas if you're using IPv4, then it uses OSPF, the older version, right? And then the distance vector that we talked about with some link state, this is EIGRP, and this is for IPv6. But if you have regular EIGRP, then that's for IPv4. Back in the day, right? RIP was around, so this is routing, it's an old routing protocol that would look at your your hop counts. Okay. So it talks about that there on page 6. Okay. So let's say that if you configure your router, which protocol is used to improve your network throughput? You want fast network, right? When we say high network throughput is good performance, you want that. So what type of routers would you use to really have faster response time? Like your packet will get there soon, right? As expected. So RIP is low, right? So you want to disable these, even though open shortest path is an option. You want to use link state and distance vector, which is EGIRP. And these are for version 4. This is going to help you improve approximately 30%. Okay, overall. There's other factor that we have to consider, like the amount of data that network is passing. There's like a lot of things, but in general, if you disable all the other options and you keep distance vector and link state, which is part of EGIRP, then in general, you improve over 25%, which is 30%. And then we want to use dynamic route. That's going to also gives us 50% increase. Okay. I mean, you open the map, you're just going to go with the best route possible, right? But your router, it's then going to update each other and with states and, it's going to also measure like the number of hops in between. Now, what happens if you have an old router and you don't have this option? right? You don't have this protocol. Then you're just gonna have a little bit slower in performance, right? Then we will have to consider getting new systems that are able to handle it. And then you also have to think about like, if that's an old router, the cable that's attached to that router, right? Like if you go using coaxial, then that's super slow compared to if you're using fiber optic, okay, in the backbone. Nobody uses like copper in the backbone anymore. Maybe somewhere really remote in the world, but in the United States in general, you have fiber optic for most larger network for the backbone.
Yeah, very important to test.
Yeah. Okay. Any question regarding routing? So I give you a very shortened Cliff Note version of this, right? Like I said, this topic alone is a course. But in general, if we're looking at like small business and home use, you just have to know like each type of protocol can give you different type of performance, right? Different ways to get things from point A to point B, right? There are variation in the service, the systems that you would get. The choice that you make in a network really represents how it's going to turn out. Okay? So network administration, that's one of the important area that we consider is like the protocols that you use, the system that you use, the media that you use to connect to it. So there's like all the elements combined. Okay. When you're troubleshooting a network, what super simple stuff should you check? These are the 4 primary things that you typically check in the case that you have slow network, problematic network, like if you have issues. Like for example, you're the technician and then all of a sudden you have like depletion in bandwidth, right? Like all of a sudden, like everybody's complaining that it's really slow. Okay. So you need to check like everybody's credential for login. Okay. And then when we say rights, that really means that accounts is capable, like the privilege. So rights really pertain to system activity. Like I have the right to connect to the internet. I have the right to shut down my computer, right? That is different than permissions. Permissions really pertain to subject acting on an object, which is what we see with like files, right? Like I have permission to share files. I have permission to save file. So you need to check like if certain people have the right to access different part of the network. And then the lights on your switches, routers are important, right? Lights represents connection, and a lot of blinking lights, amber and green, like the amber lights, if it's blinking a lot, you might have collision. Collision, a lot of collision in a network means worse performance. There's no avoidance. It's kind of like the freeway. There's going to be accidents, right? Is there going to be no accident ever? It's impossible. But so that means that when you send data on that path, the copper, the fiber, you typically would have collision. But if you have a lot of collision, your system is going to start going crazy with the lights, right? So, and we can also have administration software to really kind of to analyze the performance of our system as well. You need to make sure that your system have power and data cable and your adapter works. Okay? Because over time, wear and tear will have that issue. And then if you have users errors. So when we say user errors, it's just people making mistakes. Like typing in the wrong password, connecting to the wrong area of the network, accessing something that they're not supposed to, that kind of stuff, right? or unplug the cable and not plugging it in. Okay. All right. Pedro cannot log into the network. As a support technician, how do you troubleshoot the problem for Pedro? Right? Have them type it out and check, right? Did you type the right password? Right? And then check the account. Is he supposed to be logging into a specific system or a certain part of the network? Does he have an account on the network? I typically start with that and then check the connection, right? We want to be able to see if his wireless adapter or if his network adapter is working. The way that you see is there's a link light in the back. If it's working, you already know it's supposed to be green, right? If it's amber, then it's not sending signal. And then check the cable, because sometimes cable can be bad or loose. And then check the power for the network system, like the switch. And then check signal. Now, how can you logically check the connection after you do the physical, right? So I'm going to come back to command prompt. You've probably seen ping command already. So I'm just going to do a quick IP config so I can get my IP address. Whenever that you see 169 like this, that's not a good usable address. The operating system puts this IP address as placeholder. Okay. 169 is never used for a routable IP address. Okay. So my IPv6, because it's not configured, right? It's also like right here, but anyway, so I want IPv4. So that's my IP 10.151.101.6. So we can do a ping of our own IP. I think that's correct. Yep. So this is IPv4 address. So before each of the period, we call that an octet. So each of that value is held in 8 bits. Okay. This class doesn't include subnetting, but if you subnet, you have to know like all of these little details. And the 6 is unique to my system, right? No other system have this host ID in this particular network. So now if I ping myself, right? My system is alive, so I see 4 replies. Okay. Another way that you can ping yourself is to use a loopback address. All system have a loopback address. Right? So Microsoft, the way that it pings is that it requests 4 times and if it's alive, then it responds 4 times. And the stat that it gives you here is important. It sends 4 packets through ICMP and it receives 4, so 0 loss, 100%. But if you get reply and then timeout, whenever you see timeout, that means that you have no response. So if a system is not connected to the network, then you get timeout. Okay. Now in Linux systems, perhaps terminal and Apple, when you do a ping, right, the IP address, a lot of them don't count to 4. It just keeps going until you end it. If you want to count it to 4, you do a ping C4 and then IP address. It just keep pinging forever. Okay. So that's how we can check to see if that system is connected for troubleshooting. So if, typically if you administer system, you check server, right? You just ping the server. So if it's connected to the network, it should have an IP address and so on. So how do you troubleshoot network hardware problems? Okay. To fix it, we might reconfigure it. Changing the setting is to go in there to enable, to disable, to modify, like, sometimes we need to add the right IP address or put it on dynamic address, etc. But if your adapter is bad, typically that's a software issue. So your driver, your operating system might not give it the right driver, so you can download the driver and reinstall it. You guys know how to do that? Okay. You don't have the privilege on the computer here to do it, but you have it at home. I think I showed you Device Manager already, but in Microsoft, there's a thing called Device Manager. All the hardware is shown here, right? And when you look at network adapter, you see how earlier I saw a bunch of adapter? It's listed here as well, right? So if I'm troubleshooting my Ethernet adapter, which is this one, I would right click it, and in a higher privilege environment, you should be able to have an update driver option. Okay. I don't as a regular user. They don't want me to start running a bunch of updates, right? But at home on your own computer, you can do that if it's a Windows. So if you right click, you should be able to see update driver, or you can go to properties and the driver tab. There should be a button. See, it's hidden right here. It's grayed out. You can just click that. When that happens, it's going to prompt you two things. One is to use the one that comes with your operating system. Microsoft has generic driver to be able to handle all kinds of different type of hardware in that area for the network adapter, for example. Or you can go and if you have a file that you download, you can browse to it. I would typically look up like that adapter and see if I can go to the vendor, which is Dell, now owns Alienware, and look for that adapter and download it from their website. And then I would run the update, right? And then reboot the computer to see it works. When you reboot, right, your adapter has a chance to reset and reconnect and resubmit the signal. So that's why they tell you to reboot, is because it refreshes the network connection. At the time that the system boots, your network adapter communicates, right? It goes through the OSI layer from the physical all over again. Because if you don't reboot, it might be hanging, or it might be occupied, or it's not able to submit signal. So if you update driver, it's going to tell you to restart anyways. Okay, that's how you update driver. And then if your adapter is definitely, if you look at your adapter and the link light is yellow and you tried all of these things like update driver, reconfigure it, reattach the cable, perhaps the adapter is bad. And you tend to see that it could be produced badly, or it could be that wear and tear over time it's bad. Wireless adapter, they tend to have more a higher rate of failure over time, right? Especially the USB one compared to the actual physical one that you installed into the computer. So a user on the network cannot access a network drive or printer. How can you determine the problem is rooted at a single system or a network segment? How do you troubleshoot this problem? So the key right here is the network drive. So what does that look like? I might have a server that has a bunch of drives on there that is mapped so that way the user can put files to it. Okay. And so what that means is the drive and the printers are not able, they can't connect to it from that system. So the way that we're going to check is with a known good system, right? We talked about that in the first class. So if the person that sits next to this user is able to access the network drive and the printer, that means that this user system has some connection issue. So you would typically check to see if another network system is able to connect. Now, if 2, 3 systems are not able to connect in that office area, potentially it's the connection of those computer. The switch might be the issue, right? Or the configuration for that network segment is not allowing them to connect, or the network drive is unavailable. So it becomes like a central point versus an individual client system. Now, if the network drive is inaccessible to the next computer, to the user, then the server could be misconfigured, or that those systems are not connected properly, or sometimes it could also be that the accounts or the permission to that network drive is not allowed, right? So those are the three things that I check, right? I go to the next computer, I verify to see if I can print from that computer or I can save files to the network drive. If it does, then it's that computer, the user computer, I would troubleshoot that one. But if multiple computers in that same area is not able to print and or save files to the network drive, it's the network drive, printer connections. Ultimately, the network is the problem. Okay, that's how you can isolate that. Always test it with a known good device to start to kind of do the process of elimination. We're halfway there. Okay, I'll bring 9 down. You don't have to put verbatim, right? But we want to, I'm kind of thorough when I type out the answers so that way when you read it, you understand. And if you have questions, let me know. What happens when there is an IP address network conflict? Same IP address is assigned to multiple systems. So for example, we would not have this problem if we use dynamic IP with the DHCP. But let's say that I have 2 printers. I go and I set up the static IP address, the permanent IP address for that printer, and I forgot and I set up the same IP address for the next printer. 2 printers having the same address. That is going to cause disconnect and miscommunication in the network. Each IP address has to be unique to each system. You cannot share IP addresses, okay? So that's going to cause conflict and it might disable that segment of the network. So those 2 printers cannot be accessible, right? Typically, you know, when you set it up, it does check and it's going to tell you potentially there's conflict and you have, you know. So nowadays, like, there's also like, but in the case that, so if you manually set up IP address to put it in, you need to be able to, like cross it out, have a checklist to be able to do that. So when do we use static IP address and when do we use DHCP to give out IP address? You use static IP address for shared devices, printers, copiers, servers, things that are centralized in the network environment. You use DHCP to give out IP addresses. You saw that, like your router yesterday. For systems that are not shared across, like your computer, your laptop, your mobile phone. Now, your wireless printer at home gets its own IP address from the DHCP, right? They do that for convenience, but you can put in a static IP address. So it uses the same IP address every single time. Now, when you use a lease IP address, you saw in the router yesterday, you can have it leased for 60 days. So how can I tell, right? You did IP config all yesterday to look at your MAC address, right? So you go to your adapter, it tells you when that address was given to the system, right? And when it's gonna expire. When it expired, does it mean that it's gonna get a new IP address? It could. Typically it should, right? But if that same address is available again, it's just going to reuse it. Okay. This is a way that we can dynamically recycle the address. So that way we don't have, so if I shut down a computer for 2 months and not use it, that IP address becomes available for the next computer that asks for it when they boot. Okay, does that make sense? Okay, so we talked about IP conflict. We do not want to use the same IP for two systems. So now let's talk about interference. I touched a little bit of this when we did the cable. I touched a little bit of this when we looked at wireless yesterday. So when you're using copper, like your Ethernet cable, even with Cat6, when you twist you remember how when you assemble the cable, you untwist them to insert them into a connector? So in order to reduce crosstalk, and crosstalk is exactly what it means. So when people say crosstalk, it's like when I'm saying something, you're saying something at the same time, and no one can hear, right? All of these devices send and receive all the time. So you're going to have noisy environment. Everybody's talking at once and everybody's, so crosstalk can impede signal or deteriorate signal in that it deteriorates the signal, right? So in the Ethernet cable, what you see, or the copper cable, you have the wires are twisting together. If you place them at 90-degree angle to each other, right, then that would really reduce crosstalk, okay? Or you just use a new category. So if I use Cat5e, I tend to have more crosstalk compared to Cat6 because Cat6 is really designed for more reliability and faster speed. So the type of cable, the category of cable you use for Ethernet is important. If you ever seen picture of server rooms, right, racks, you have a lot of cables combined together, right? And all of that is very noisy. Copper is very, very noisy. It's cheaply implemented. That's why we keep using it. And it lasts a long time. Okay. Next term is attenuation and latency. Attenuation means that your signal is degrading, it's reduced, it's lessened. It's kind of like you hear a song or you're listening to the radio, and the farther you are from the radio station, right? You tend to not hear what they're saying or singing or whatever, right? You can't hear that signal. So attenuation tend to be that there is something impeding the signal or you're far from the source. And that this is in all area, wired or wireless. And then you have latency. The term late is here, so you know that it is a delay in signal. And so the way we fix this on the network is if you have attenuation, if you have signal deterioration, you use a repeater, an amplifier, or use a different type of cable, which is fiber. So if you're using copper, maybe it can't reach a certain area, and if it does, it's going to be low in signal, then you should replace it with fiber. Or a way that we can do this is we can use a physical repeater to take that signal and then repeat it down toward that distance, right? So the difference between a repeater and an amplifier, if you ever use audio, you know what an amplifier does, right? But an amplifier, to amplify is to take that signal and increase it. So that way you can hear song clearly, right? Like you have the boom boom in your car, where the repeater take that signal and regenerate it down. So the way that we fix latency is we would lessen the rules on the router, because the router follows the rule to check, right? So it's kind of like you have to do something quickly, but you can't do it without checking with your family members. And if they have a lot of rules, then you can't go and do it. You have to listen to all the rules and follow the rules first, right? Then you also need to test security settings. So outside of router and switch, we have firewall, right? We have security appliances, and those have lots of rules. Like IP address that's not knowledgeable to it, it's gonna block, right? So it follows rules. Your wireless router at home has that, right? Yesterday, remember we talked about MAC filter? So the rule that it follows is to check to see if the MAC exists on the list. If it does, allow, right? If it doesn't, deny. And that's the function of a firewall. So we want to test the security settings on these appliances and other security settings on other appliances that potentially control security. And we have a system, and also some system have feature on load balancer. I'm going to describe to you how load balancer works. So the way that we load balance is we can specify the priority of the system's communication. So for example, you're driving, lots of cars on the road, and the fire truck goes down, or the ambulance goes down. You follow the rule, right? What do? You pull over to the right, and you let the priority vehicle go. Okay. The way that we regulate that on the load balancer is we can say, or also like, for example, you're driving on the freeway, and let's say that there is a way that if there's an accident, the police is going to come and move everybody into a certain lanes, and so that way you can move on, right? So if you have congestion, what we can do is we can redirect the traffic, specify it so we can have a certain type of load. Like when it reaches 80% congestion, then we will be able to send it into other systems so that way it can have throughput. Okay. And that's part of quality of service in network communication, and that's really important. That's a job for the network administrator and the technician within, right? Because if you don't have throughput and if your network is not up by 99.9999%, then you're not doing the job. Okay. All right, so let's talk about some more term. We still have a little bit to go. So how can you reduce jitter? And in the wire connection, how can you reduce wireless or jitter or collision? So for jitter in your cable environment, you can think about like the files that you transfer, and then you want to route those packets. So you want to remember, we can load balance that. So set up your router to queue those large to reduce the large packet. So redirect the traffic in such that, like, if you have a lot of large files that's being sent through that can cause congestion, then you would manage the router. For the wireless side, we want to reduce the number of devices connecting to it. Can you kick them off? No, right? But instead of having one access point, maybe having 4 access points or more routers. Now, I talk about how you can have collision on the network. So collision is typical, right? But you don't want to have more than it should. So to reduce collision, we have a thing called CSMA-CD. It's called Carrier Sense Multiple Access with Collision Detection. So it checks. And if there's collision, right, it typically would have some kind of notification, but the way that you can configure it is that you would use switches to divide it up. So it's kind of like having many detours to avoid people driving and causing accidents. Just redirection. and we would create what's called a virtual circuit. Any question? All right, let me move 14 up. Okay, ABC Corp uses 2 wireless access point for employee for wireless connection. During regular operation, there are more than 120 users connecting to each access point. They complain that the network bandwidth is low and downloads are very slow. That is we already know too many people on 2. What is the cause of the problem? How can you improve it to have higher bandwidth? Too many devices connecting to each access point. When you reach 120, remember that it's centralized to those access point and then the router, right? Through the switch. So you have bandwidth saturation. To improve it, we want to double or more. So add 2 more access point. And so you have 240 users on 2 access point. Then if you divide it up equally, so 240 divided by 4, that gives you 60 devices on each access point. So you have less bandwidth saturation for the user. But this type of question, if I'm the network admin looking at this, right, or an analyst, I would say there's other factor that you have to consider too. What's the backbone look like? Does it have fiber? How many devices? Like, are all the AP connecting to only one uplink switch? We can probably redirect, and then we can look at like load balancer. But based on what the problem is given, we already know there should not be 100 and something user on each AP. Anytime that you reach over 100, your AP is gonna be slow. Okay. So, yeah, typically you want less than 100 user per AP. And also the type of access point you're using, stuff like that, configuration for it. So there's like a lot of other things we have to look at in addition to adding AP. But that will be the start. All right, we talked about signal bouncing yesterday because of wireless. So how can you control signal bounce on a wireless environment? Use better antenna on your access point. And we can ignore out-of-phase signal. So ultimately, antennas are used to send signal, right? So if your antenna is not equipped to handle the signal, then you tend to have that. But you also have like other elements, natural and man-made elements that will bounce signal. So whenever that you guys ever have experience where you go see a concert or music festival or sport game and you cannot post things on social media, right? Because they charge for streaming and they don't want you to record stuff and put it on YouTube or your Instagram or whatever, right? They use Shield, and Shield blocks your wireless signal. Okay. Can you do this at home? Technically, you cannot build signal blocker without the FCC approval. It lands you in prison. I'm going to tell you a story about my drone, right? So my neighbors fly drone just to look at people's backyard. Now companies are flying drone to look at for insurance purposes. They're not supposed to. In California in general, that's trespassing, right? It's like you jumping the fence, going into someone's yard and look around. That's trespassing. So I had drone problem a while back and I'm going to handle it, right? I've talked to them and they don't want to acknowledge. So I looked into a way to not let the drone fly over my house. So you can build devices at a cheaply cost from parts from China. but it's not legal, right? So, you know, now can I add other things to bounce signal? Drone is controlled wirelessly too. But what I did was I bought a drone ID because technically now when you fly drone, you're supposed to register your drone, but they don't always register the small drone, right? But whenever they fly their drone, I would be able to detect whose drone that is. Right? It's kind of like seeing the license plate of the car and know who owns that car. Um, but that doesn't really do very much. But yeah, I did. If you're curious, look up like YouTube. They have full tutorial on how to do it. And I did buy the component. I just never put it together. Yes.
So do we get extra credit for helping you?
I don't want you to get in trouble. Yes, question?
Yeah. It's like a White House over your backyards.
Yeah, people say that I have a lot of sun sail, which are like those sun blocker things, so you can't really see a lot. But they're not supposed to fly below tree level. They still do, right? And then also like they can fly it at a certain angle. Sun sail doesn't block everything, right? But some city they have problems with people doing that, so that way they can check out what you have in your house, for malicious purposes. Yeah, so I don't think they do that. They're just being nosy, or sometimes people fly for, I don't mind if people flying for fun, flying across, but there's purposely parking it and looking, and they have cameras, so it's recording. And I just didn't like that. So yeah, if you can identify who they are, you can file for trespassing, but if you don't identify who they are, so that kind of slows it down a little bit. They haven't done that while I'm home. And I have security cameras, so if they do fly it, I see it. Yeah, their military has a drone shooter. So you've seen videos maybe where they have these things that launch nets to take down drone, and also they have it's not legal in the United States for regular use, but they have a weapon where you can, it's like they call it the drone gun. So what it does is it emits signal and it cuts the signal of the controller to the drone, so the drone just drops. And that's how military takes out the drone. Yes, right. But in the military, you just blow up drones, right? They fly drone to blow up drones.
Long thing going on, the for weeks over the US.
Yeah, I think that was over New Jersey or something like that I read, right? Yeah, unknown device. And so they were just like looking at it. But anyway.
But also they were collecting data.
Yep. So, authority, if it's an unknown device to the US, they do have the authority to do something about it, right? But if you have drones over your property, then it is an unknown device and they're trespassing. Okay. You can. Yeah, if you build a device to do that without FCC approval, 25 years to life in prison. It's intermittent in communication without government approval. And because they don't want you to do that to military drone, you see? That's why it's regulated. There's a reason. Okay, the cost for indoor RF signal refraction. So think of refraction as a cost of signal degradation. So I mentioned to you glass and water does that, right? Like big fountain. I'm not talking about like, uh, so big fountains and glass walls, stuff like that will also refract. What should you do when you cannot confirm the theory and the cost of a network issue? You should escalate the problem, or you derive a new theory. You create a new theory. And this is just part of the troubleshooting, right? So when you find the solution, just like when we talk about hardware and computer maintenance, you want to document it. So that way you have that information in case it comes up. In security and IT, we do this so that way, because similar things is going to come up or the same things going to come up. And then lastly, what command do you use in the case where you cannot connect to your network, right? Like let's say you're trying to log into RCCD and it tells you you cannot log in and you know you type your password correct. So you check the way that you check the domain is through command line like this, right? You ping, you know that you connected to, you have an IP address, but see how on here it has a DNS, right? DNS is used for domain for that network. And DNS also is used with web server for the domain name that you see. So those are public DNS. Internal DNS, we use it for connecting our system to the network, right? So what we have is we can do NS lookup, one word, and it tells you that the server that you're connecting is that, and this is its IP address. The way that you get back to your pop-up, which you type exit. And then if you exit again, it closes your command prompt. So that's how you find your DNS server. You can also find it in ipconfig all the information, but sometimes they don't disclose it there. NS lookup always tells me that I am connecting to this domain server. Now, this is internal to local area network, right? But for the web server, they are public DNS. They have to be registered with the entity for public DNS. So that's why when you buy a domain name like, mybusiness.com or something like that, that's tied to that public DNS. And it has an public IP and all of those things. So you would use a host company. They have those already. You just lease it. Okay, any question?
There are too many.
Too many questions. So hopefully this gives you the basic information on just like how to look things up, how to troubleshoot a little bit, how to work with your media, wireless or wired, and then how the routers work. So in the case that you're using your router, you can see now how it brings your information into and out of your network. That's good, because that way you understand communication a little better, right? In the case that if you have failed communication, then you can start working through it. I mentioned before, I'm going to say it again. If you do want to pursue cybersecurity, you have to be very strong in this area. The majority of security professional are network defender, right? We protect the information for every networks that we work under, right? Sometimes you work for a service provider, you protect their network. And then you also, so that's blue team. And then you have the red team, where the people who test your network to see the flaws, what needs to be protected. Those are the ethical hacker, and then you have different level of that. So everything comes back to network systems, right? And protocols and so on. I have to update my Network Plus class for this upcoming fall because I'm going to start addressing the new protocols for AI data center. They use different set of rules for sure. Yeah, I saw someone's post on LinkedIn the other day, and then somebody had posted something else. They're like, wouldn't you want to learn the basic first before you learn this? And somebody else said that, well, if you're not catching up with AI, then you're behind. That's true, because soon enough, you're going to have internal data center or your own servers that are running AI. So you have to be able to configure it. We're not going to have a lab today. I'm probably going to have to take off real soon because I have to get ready to go for the trip. But what I will do is I want to remind you. So let me stop recording.